Hello students, today we are going to solve exercise 3.3 from chapter number 3. Let us start. You can see in question 1 to 5, 1 to 4, we have to prove LHS to RHS, for which we should know the value of sine, cosine and other trigonometric terms. Okay. Let us start doing this. So let us start from question number 1. LHS, wherein it is given sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4. We know the value of sine pi by 6, that is equal to 1 by 2, so it's square. Cos pi by 3, that is equal to root 3 by 2, sorry, it is also 1 by 2, so 1 by 2 whole square minus tan pi by 4, value is 1, so it's square. That comes out to be 1 by 4 plus 1 by 4 minus 1, that is equal to half minus 1, comes out to be minus half, that is equal to RHS. Hence proved. Okay. Let us take question number 2. Okay. So LHS is equal to 2 sine square pi by 6 plus cos x square 7 pi by 6 into cos square pi by 3. So here this 7 pi by 6, there is an angle whose value we don't know, so we'll convert it into simple angles ranging between 0 to 2 pi. Okay, let's try to solve this. 2 sine square pi by 6 plus cos x square, so we can split this 7 pi by 6 as pi plus pi by 6 into cos square pi by 3. Let's put the values that we know. We already know, that is like sine pi by 6, we already know its value is 1 by 2, so 1 by 2 whole square plus this cos x square pi plus pi by 6 will convert into minus cos x pi by 6 whole square, right? And this is the cos square pi by 3, its value known to us, that is 1 by 2 whole square, so this will be 2 into 1 by 4, so it will become cos x square pi by 6 only. This is 1 by 4, so this is 1 by 2 plus 1 by 4 into, oh my mistake, this is not cos square, this is cos x square. Okay. And its value is 2, so 2 square, that comes out to be 1 by 2 plus 1 by 4 into 4, that is 1 by 2 plus 1, which comes out to be 3 by 2 is equal to RHS. So hence LHS is equal to RHS, hence proved, right? Let us take the third question now. Okay, so here LHS is cot square pi by 6 plus cosec 5 pi by 6 plus 3 tan square pi by 6. Okay, right. So cot pi by 6, the value of cot pi by 6 is root 3. So it will become root 3 square plus, we can convert this angle ranging between 0 to pi by 2. It will become cosec pi minus pi by 6 plus 3. The value of tan pi by 6 is 1 by root 3. So 1 by root 3 whole square. This will become 3 and this will become cosec pi by 6. This is 3 into 1 by 3. So this comes out to be 3 plus the value of cosec pi by 6 is 2 and this is 1. So the final answer is 6. Hence LHS is equal to RHS. Hence proved. Right? Let us solve the fourth question. Let us write down LHS as 2 sine square 3 pi by 4 plus 2 cos square pi by 4 plus 2 sec square pi by 3. So this comes out to be 2. Here we need to convert this angle, 2 sine square pi minus pi by 4, right? And here the value of cos pi by 4 is 1 by root 2, so 1 by root 2 whole square plus 2. Value of sec pi by 3 is 1 by 2, sec pi by 3 is 2, right? So 2 square, and this will be 2, this will become sine square pi by 4 plus 2 into 1 by 2 plus 2 into 4. This will cancel out each other. 2, the value of sine pi by 4 is 1 by root 2, 1 by root 2 whole square plus 1 plus 8. This will become 2 into 1 by 2 plus 1 plus 8. So finally it would be 1 plus 1 plus 8, that is equal to 10, right? So we have got the value of LHS equal to RHS, hence proved. Let us jump to the next question of the exercise, that is question number 5. We need to calculate value of sine 75 in the first part. So again need to convert this angle, so we can do it as sine 45 plus 30 degree, right? Now using the identity sine A plus B is equal to sine A cos B plus cos A sine B, right? We would get sine 75 is equal to sine A, that is 45 degree, cos B, that is cos 30 degree, plus cos A, that is cos 45, sine B, that is sine 30 degree. So it will become sine 45 is 1 by root 2, cos 30 is root 3 by 2, plus cos 45 is 1 by root 2, and sine 30 is 1 by 2. So it will become root 3 by 2 root 2 plus 1 by 2 root 2. That is, taking LCM, it will become 2 root 2, numerator means root 3 plus 1. Okay, this is the value of sine 75. Now you can rationalize it by multiplying root 2 on numerator and denominator side. It will become root 6 plus root 2 upon this is the value of sine 75. Now we need to calculate the value of tan 15. Let us do this. So here, instead of adding those angles, we can subtract tan 45 minus 30 degree, and now we need to use the identity of tan A minus B. So using identity tan A minus B is equal to tan A minus tan B upon 1 plus tan A tan B, right? So we'll get the value of tan 15 as tan A, where A is 45 degree, minus tan B, where B is 30 degree, upon 1 plus tan 45 tan 30, right? So we get 1 minus 1 by root 3 upon 1 plus 1 into 1 by root 3, right? Taking LCM on the numerator side, we will get root 3 minus 1 whole divided by root 3 upon, taking LCM on the denominator side, root 3 plus 1 whole divided by root 3. So we will get root 3 minus 1 upon root 3 plus 1. This is the value of tan 15 degree, or we can rationalize here by multiplying root 3 minus 1 on numerator and denominator side. It will result in root 3 minus 1 whole square upon 3 minus 1. Okay. Here we get 3 plus 1 minus 2 root 3, using identity a square, a minus b whole square is equal to a square plus b square minus 2ab. Okay, and denominator side we get 2. So 4 minus 2 root 3 upon 2, that is 2 minus root 3. So this is the value of tan 15 degree. Right. Let us jump to the next question. Question number 6. Okay. Let pi by 4 minus x be equal to a, and pi by 4 minus y be equal to b. So the LHS becomes cos A cos B minus sin A sin B. Okay, we know this is an identity of cos A plus B. Okay, so this will become cos A plus B. Substituting the values we assumed, we will get cos pi by 4 minus x plus pi by 4 minus y. Okay, this will become cos. If we add this pi by 4 and pi by 4, we will get pi by 2. So cos pi by 2 minus x minus y. Taking minus sign common, we will get pi by 2 minus x plus y. So we know that cos pi by 2 minus theta is equal to sin theta. So this will become sin x plus y, which is equal to RHS. Hence proved. Let us do the next question. That is question number 7. Okay. LHS, that is equal to tan pi by 4 plus x upon tan pi by 4 minus x. So using the identity of tan A plus B and tan A minus B, you know that tan A plus B is equal to tan A plus tan B upon 1 minus tan A tan B, right? And tan A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. Okay, let's use these identities to get our answer. Tan pi by 4 plus tan x upon 1 minus tan pi by 4 tan x whole divided by tan pi by 4 minus tan x upon 1 plus tan pi by 4 tan x. Okay, this will become tan pi by 4, the value of tan pi by 4 is 1, so 1 plus tan x upon 1 minus tan x, because this tan pi by 4 is also 1 and this is also 1, same way this is also 1 and this is also 1. So we write down their values in the bracket. Okay, so 1 plus tan x upon 1 minus tan x, same way in the denominator 1 minus tan x upon 1 plus tan x. So it will become 1 plus tan x upon 1 minus tan x, numerator as it is, and when we convert divide into multiply sign, we will reciprocal the denominator. So 1 plus tan x upon 1 minus tan x. So this will become 1 plus tan x upon 1 minus tan x whole square, which is equal to RHS. Hence LHS is equal to RHS. Let us solve the next question. That is question number 8. Okay. LHS is equal to cos pi plus x into cos minus x upon sin pi minus x into cos pi by 2 plus x. So we know that, let me write down first, cos pi plus x is equal to minus cos x. Okay, and sin pi minus x is equal to sin x. Cos minus x is equal to cos x, and cos pi by 2 plus x is equal to sin x. Okay, so let me substitute these values in the given question. This will become minus cos x, this will become cos x, upon this will become sin x, and this will become sin x. Okay, have I done some mistake? Let me find. Oh yes, cos pi by 2 plus x is equal to minus sin x instead of x. So this will become minus sin x, right? So we'll get minus cos square x upon minus sin square x. Minus minus cancel out each other, so it will become cos x plus sin x whole square, that comes out to be cot square x. Hence LHS is equal to RHS. Let us jump to the next question. That is question number 9. LHS is equal to cos 3 pi by 2 plus x into cos 2 pi plus x whole bracket cot 3 pi by 2 minus x plus cot 2 pi plus x. Okay, a bit complicated question, not a problem. So we can convert this. So here the angle is a multiple of pi by 2. So we will convert cos into sine, right? And the angle will keep as x only. And since this angle lies in the fourth quadrant, so the sign will be positive only. If you want detailed information on how to convert these angles, you can watch our session. The tag is given at the top. Okay. So this is converted into sin x, and then cos 2 pi plus x will be cos x, right? And cot 3 pi by 2 minus x will convert into tan, and angle will remain x, and the sign is positive because in the third quadrant the angle is in third quadrant, and in the third quadrant we have cot positive only. Okay, now this will become cot x. Okay, let's try to solve this. Multiplying this, we will get, opening the bracket, we will get sin x cos x into tan x plus sin x cos x into cot x. Let's elaborate that. Tan x and cot x will get sin x on cos x plus cos x upon sin x. So they will cancel out each other, cos x, and here sin x, sin x. So ultimately we'll get sin square x plus cos square x, which is equal to 1. Hence LHS is equal to RHS. Hence proved. Okay, let us jump to the next question. That is question number 10. Okay. LHS is equal to sin n plus 1x sin n plus 2x plus cos n plus 1x and cos n plus 2x. So again, let n plus 1x be a and n plus 2x be b. Okay, let's replace these angles. So our LHS will become sin a sin b plus cos a cos b. Okay. Multiplying and dividing by 2, we will get this equation. So solving the numerator, 2 sin a sin b plus 2 cos a cos b upon 2. This will give, 2 sin a sin b will be cos a minus b minus cos a plus b. You can check the identity if you have any doubt. Plus cos a plus b plus cos a minus b upon 2. So you can see that we have opposite signs in front of cos a plus b, so we can cancel out them. So we'll get twice of cos a minus b upon 2. This is equal to cos a minus b. Substituting the values back into the equation, the values of a and b, will get n plus 1 x minus n plus 2x. So it will become cos nx plus x minus nx minus 2x. So this nx cancel out each other and we'll get cos minus x, which is equal to cos x only. Okay, and this is equal to RHS. Hence proved. Let us jump to the next question. Question number 11. Okay, LHS we have given cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x. So there are multiple ways to solve this question and I am using only one of them. So you may have the other options to solve this question. Okay. First, I'll split the angle 3 pi by 4 and I can do that by pi minus pi by 4 plus x minus cos pi minus pi by 4 minus x. Like grouping them, it will make this, and the second angle will become this, taking minus common from pi by 4 and x. Okay, and here I have taken minus common, so it is forming pi by 4 minus x. So using identity, okay, no need to use identity, I have cos pi minus theta is equal to minus cos theta. This we already know. Okay, so I'll apply this in the above equation. Is equal to minus cos pi by 4 minus x, then minus and minus will become plus. Okay, plus cos pi by 4 plus x, right? Okay, so now elaborating them using the equation of cos a minus b. Let me write it. Cos a minus b is equal to cos a cos b plus sin a sin b, and cos a plus b is equal to cos a cos b minus sin a sin b. So using these identities, I'll get LHS as minus common cos a cos b plus sin a sin b, right? And the other, I'll get cos a cos b plus sin a sin b. Okay, so now I'll get minus common. Cos pi by 4 is 1 by root 2, 1 by root 2 cos x plus 1 by root 2 sin x plus 1 by root 2 cos x plus 1 by root 2. Sorry, here it was minus. Okay, so I'm going to use minus here. Sin x. So this will become minus 1 by root 2 cos x minus 1 by root 2 sin x plus 1 by root 2 cos x minus 1 by root 2 sin x. Right? So it can be seen that they have opposite signs, so we can cancel out them and we'll get minus 2 upon root 2 sin x. this is basically minus root 2 into root 2 upon root 2. Just for your explanation, otherwise it is not required. You can directly cancel out them and you will get minus root 2 sin x, which is equal to RHS. Hence LHS is equal to RHS. Okay. Let's do next question. That is question number 12. Okay. LHS is equal to sin square 6x minus sin square 4x, right? Okay. So we can use the identity of a square minus b square. So a plus b into a minus b. Okay, using the identity of sin a plus sin b, which is equal to 2 sin a plus b divided by 2 into cos a minus b divided by 2, and sin a minus sin b, which is equal to 2 cos a plus b upon 2 into sin a minus b divided by 2. So using these identities, we'll get LHS is equal to 2 sin 6x plus 4x 10x divided by 2 into cos 6x minus 4x, that is 2x divided by 2. Okay. This we have got from the first bracket. From the second bracket, 2 cos a plus b, that is 10x divided by 2 into sin a minus b, that is 2x divided by 2. So it will form 2 sin 5x cos x into 2 cos 5x into sin x. Let's keep 5x terms together and x terms together. Okay, so it will form, I've just switched them. Okay, so using the identity 2 into sin a, 2 sin theta cos theta is equal to sin 2 theta. Okay, this and this. By using the identity 2 sin theta cos theta is equal to sin 2 theta. Right. Okay. I've got LHS is equal to sin 2 into 5x dot sin 2 into x. So it is sin 10x dot sin 2x, which is equal to RHS. Hence root. Okay. Let's jump to the next question. That is question number 13. Similar kind of question, right? Here we have LHS is equal to cos square 2x minus cos square 6x. Again, using the identity a square minus b square, I'll get cos 2x plus cos 6x and cos 2x minus cos 6x. Okay. Using the identity of cos a plus cos b, I'll get 2 cos a plus b, that is 8x divided by 2 cos a minus b, that is minus 4x divided by 2. And here I'll get minus 2 sin a plus b divided by 2, that is 8x divided by 2 into sin a minus b divided by 2, that is minus 4x by 2. Okay. So here we will get 2 cos 4x cos minus 2x into minus 2 sine 4x into sine minus 2x. So this minus will cancel because cos minus x is equal to cos x only, so इस minus का कोई फर्क नहीं पड़ता. And this minus sine minus 2x, इसका minus आपको ब्रैकेट के बाहर आएगा, साइन के बाहर आएगा, and will multiply by this minus sign. Okay, so will give us positive. So 2 sine 4x into sine 2x. Same thing, we'll rearrange them so that 4x terms come together and 2x terms come together. So 2 sine theta cos theta is sine 2 theta, that means sine 8x, and here it will become sine 4x, which is equal to RHS. Hence proved. Let us jump to the next question, that is question number 14. So here we have LHS is equal to sine 2x plus 2 sine 4x plus sine 6x. So we'll basically split the middle term, okay, sine 2x plus sine 4x and then plus sine 4x and sine 6x. So grouping them into sine 2x, sine 4x. Again, I can say that there are multiple ways to solve this question. I am using one of them. So sine A plus sine B will become sine A plus B divided by 2, that is 6x upon 2 into cos A minus B, that is minus 2x upon 2, right, plus 2 same identity sine 10x divided by 2 dot cos minus 2x divided by 2. Okay, this will be 2 sine 3x cos minus x plus 2 sine 5x cos minus x, right? Or we can say it is cos x only, because negative angle in cosine doesn't matter. Taking 2 cos x common, I'll get sine 3x plus sine 5x. Okay, so using same identity, it is 2 sine A plus B divided by 2, that is 8x divided by 2. Let me write it again, 8x divided by 2, and cos A minus B, that is minus 2x divided by 2. So it will be forming 2 cos x, 2 sine 4x into cos minus x. As we know, negative sign and cosine doesn't matter, so it will form 2 sine 4x into cos x. So this is 2 multiplied by 2, it will form 4 cos x multiplied by cos x, it will form cos square x into sine 4x, that is equal to RHS, hence proved. Let's do the next question. That is question number 15. LHS is equal to cot 4x sin 5x plus sin 3x. So this will become cos 4x upon sin 4x. Here I'll use the identity of sin A plus sin B, that will be sin A plus B, sin A plus B divided by 2 into cos A minus B divided by 2. Right? This will be cos 4x upon sin 4x into sin 4x into cos x. So you can see that these are sin 4x and sin 4x, they will cancel out each other. So it will be forming 2 times cos 4x into cos x. Okay, we'll separately solve the RHS, okay, and try to get it equal to the LHS. So this is given as cot x. In the bracket we have sin 5x minus sin 3x. So elaborating them, we'll get, using the identity here of sin A minus sin B, we'll get 2 cos A plus B divided by 2, that is 8x divided by 2, into sin A minus B divided by 2, that is 2x divided by 2. So this is cos x upon sin x into 2 cos 4x into sin x. So here also we can see that sin x and sin x are cancelling out each other. So ultimately we are getting 2 cos 4x into cos x, which is equal to LHS. Okay. So both LHS and RHS are equal, hence LHS is equal to RHS. Let's jump to the next question. That is question number 16. LHS is given as cos 9x minus cos 5x upon sin 17x minus sin 3x. Okay. So using the identities of cos A minus cos B as minus 2 sin A plus B divided by 2 sin A minus B divided by 2 and sin A minus sin B as 2 cos A plus B divided by 2 into sin A minus B divided by 2. So our LHS will become minus 2 sin A plus B, that is 14x divided by 2 into sin A minus B, that is 4x divided by 2 upon 2 cos A plus B, that is 20x divided by 2 into sin A minus B, that is 14x divided by 2. So it will be forming minus 2 sin 7x sin 2x upon 2 cos 10x into sin 7x. So this sin 7x and sin 7x cancel out each other, and 2 also cancel out each other. We will get minus sin 2x upon cos 10x, which is equal to RHS. Hence proved. Let us jump to the next question. That is question number 17. We have LHS is equal to sine 5x plus sine 3x upon cos 5x plus cos 3x. Again, using same kind of identities, we'll get 2 sine 8x divided by 2 into cos 2x divided by 2 upon 2 cos 8x divided by 2 into cos 2x divided by 2. This will form 2 sine 4x cos x upon 2 cos 4x cos x. So cos x and cos x cancel out each other, 2 and 2 cancel out each other. So ultimately we are getting sine 4x upon cos 4x, that is equal to tan 4x, is equal to RHS. Hence proved. Let us jump to the next question, that is question number 18. So LHS is equal to sin x minus sin y upon cos x plus cos y, right? Using the same identity, 2 cos x plus y by 2 into sin x minus y by 2 upon 2 cos x plus y by 2 into cos x minus y by 2. So we can see that 2 and 2 cancelling out each other, cos x plus y divided by 2 cancel out each other. So we are getting sin x minus y by 2 upon cos x minus y by 2, that is equal to tan x minus y by 2. This is equal to RHS. Hence proved. Let us jump to the next question, that is question number 19. LHS is equal to sin x plus sin 3x upon cos x plus cos 3x. Okay. So using the identities, 2 sin a plus b, that is 4x divided by 2 into cos a minus b, that is minus 2x divided by 2 upon 2 cos a plus b divided by 2, that is 4x divided by 2 into cos a minus b divided by 2. So 2 and 2 cancel out each other. Okay, cos minus 2x by 2 minus 2x by 2 cancelling out each other. So we are getting sin 2x upon cos 2x, that is equal to tan 2x, which is equal to RHS. Hence proved. So next question, that is question number 20. LHS is equal to sin x minus sin 3x upon sin square x minus cos square x. So using the identities, okay, one identity we can use here directly. We know that cos square x minus sin square x is equal to cos 2x, or we can write down as sin square x minus cos square x is equal to minus cos 2x. So this we are going to use here directly. Okay. On the upper side we can use 2 cos a plus b divided by 2, that is cos 4x divided by 2 into sin minus 2x divided by 2 upon minus cos 2x, that I have told you can use directly here. Okay. So this will be 2 cos 2x into sine minus x upon minus cos 2x. So cos 2x cancel out each other, and this minus will come the front, so minus 2 sin x upon minus 1. It will be forming 2 sin x, which is equal to RHS. Hence proved. Let us jump to the next question. That is question number 21. LHS is equal to cos 4x plus cos 3x plus cos 2x upon sin 4x plus sin 3x plus sin 2x. So simply check it that on the right hand side we have the angle 3x. We want the angle 3x. Okay. So let's keep cos 3x and sin 3x as it is, and we'll try to solve this cos 4x and cos 2x. When we have 3 terms, we have to choose appropriately so that we can get the required answer. Okay. So let's rearrange it first. Cos 4x plus cos 2x plus cos 3x. We'll keep the last one cos 3x as it is. Same way on the denominator side, sin 4x plus sin 2x plus sin 3x, because we'll keep sin 3x as it is. We'll apply the identity only on the first 2 terms. Okay. So we'll get 2 cos 6x divided by 2 into sin 2x divided by 2. Sorry, here also cos 2x divided by 2 plus cos 3x as it is. Okay. This is just from the bracket we have solved. So same way on the denominator side, 2 sin 6x divided by 2 dot cos 2x by 2 plus sin 3x. So you get 2 cos 3x cos x plus cos 3x upon 2 sin 3x cos x plus sin 3x. Taking cos 3x common from numerator, we'll get 2 cos x plus 1, and taking sin 3x common from the denominator, we'll get 2 cos x plus 1. So that term, bracket term, is same on the numerator and denominator side. We can cancel out them. So we'll get cos 3x upon sin 3x, which is equal to cot 3x, and this is equal to RHS. So hence LHS is equal to RHS. We have proved that. Let's jump to the next question. That is question number 22. Cot x cot 2x minus cot 2x cot 3x minus cot 3x cot x. Let's solve the last 2 terms first. So cot x cot 2x, taking the minus cot 3x common, we'll get cot 2x plus cot x, right? So cot x cot 2x minus cot 3x cos 2x upon cos 2x upon sin 2x plus cos x upon sin x. Taking the LCM, sine 2x into sine x. This will become sine x cos 2x plus cos x sine 2x. Right? This is the identity of sine a plus b, sine a cos b plus cos a sine b. So let's use that identity. Sine a plus b, that will become sine 3x So now elaborating this cot 3x as cos 3x upon sine 3x, we'll get cos 3x upon sine 3x. Sine 3x and sine 3x will cancel out each other. So finally, we'll get, let's take it on the next sheet. So we'll get LHS as cot x cot 2x minus cos 3x upon sine 2x into sine x. Let's elaborate first part now. Cot x, let's rewrite cot x as cos x upon sine x and cot 2x as cos 2x upon sine 2x. Now taking the LCM, we get sine x sine 2x as denominator, and on the numerator side we'll get cos x cos 2x minus cos 3x. Okay, let's use the identity here. Cos x into cos 2x. Let me rewrite the identity first. Cos a into cos b is equal to half of cos a plus b plus cos a minus b. Okay. So this will be forming LHS is equal to half of cos a plus b, that is cos 3x into plus cos a minus b, that is minus x, minus cos 3x upon sin x into sin 2x. Taking this, okay, let's take this on the sheet. Taking LCM on the numerator side, we'll get, or we can say taking half common, we'll get cos 3x plus cos x, this cos minus x will become cos x only, minus 2 cos 3x. On the denominator side we have sin x into sin 2x. This will be forming cos 3x minus cos 3x, okay, cos x minus cos 3x. One positive cos x, cos 3x, 2 negative cos 3x. So it will be forming minus 3x, cos 3x, okay, upon 2 sin x into sin 2x. Again, using the identity, which identity? Cos a minus cos b, which is equal to 2 times, minus 2 times sin a plus b divided by 2 into sin a minus b divided by 2. We'll get minus 2 sin 4x divided by 2 into sin minus 2x divided by 2. So this will be minus 2 sine 2x sine minus x. So taking minus side, minus in front of it, we'll get 2 sine 2x into sine x upon 2 sine x into sine 2x. All the values are same on the numerator and denominator side. They'll cancel out each other. So we'll get 1 which is equal to RHS. Hence proved. Let us jump to the next question. That is question number 23. So we have LHS is equal to tan 4x. We can write down it as tan twice of 2x. So using the identity tan 2a is equal to 2 tan a upon 1 minus tan square a. Using this identity, we will get 2 tan 2x upon 1 minus tan square 2x. Okay, so now again we have to apply this identity of tan 2a on the numerator and denominator side. So we'll get 2 tan x upon 1 minus tan square x on the numerator side. Not a bit difficult, but on the denominator side we have tan 2x and its square. Okay, so 2 tan x upon 1 minus tan square x and its square. Let's keep the numerator as it is for the time being, so that you don't get confused with the calculation. Okay, and let's take the LCM here. Okay, 1 minus tan square x whole square, 1 minus tan square x whole square minus 2 tan x square. So we get 2 times 2 tan x upon 1 minus tan square x. This was the numerator part as it is. Multiply, we will reciprocal the denominator part. So we get 1 minus tan square x whole square upon 1 minus tan square x whole square minus 2 tan x whole square. Okay, so we can see that on the denominator side we have only 1 minus tan square x, and on the denominator side we have its square. So we cancel out their power. Okay, this will result in 4 tan x upon, let's elaborate the bracket here, a square plus b square minus 2ab. Right? This was the first bracket. Then minus 4 tan square x. This was the second bracket. Solving this, we'll get 4 tan x upon 1 minus 6 tan square x plus tan 4x. This was the RHS. Hence proved. Let us jump to the next question. That is question number 24. We have to use the same technique. LHS is equal to cos 4x, which is the double of 2x. So now we can use the identity of cos 2x as cos square x minus sin square x. So it will become cos square 2x minus sine square 2x. And now we have to use the identity of sine 2x also, which is 2 sine x cos x, right? So this will be cos square 2x. Okay, a mistake here. We can use the other identity of cos 2x. It will make the question simpler. That is 1 minus 2 sine square x. Okay, so instead of using this identity, I am going to use this identity. So let's cancel this, and our equation will become 1 minus 2 sine square 2x. So it will be 1 minus, now we can use this identity, 1 minus 2 sine x cos x whole square. So it will be 1 minus 2 4 sine square x cos square x, that is 1 minus 8 sine square x cos square x, which is equal to RHS. Hence proved. Let us jump to the next question, that is question number 25. So LHS, we have cos 6x, which is equal to cos rise of 2x. We know the identity of cos 3x. Cos 3x is equal to 4 cos cube x minus 3 cos x, right? So using this identity, we'll get 4 cos cube 2x, because here the angle is 2x. Okay, 4 cos cube 2x minus 3 cos 2x. Now we have to use the identity of cos 2x. All the terms are in cos, so let's use this identity, cos square x, 2 cos square x minus 1. Okay, so we get 4 2 cos square x minus 1 whole cube minus 3 2 cos square x minus 1. So we get, using the identity of a minus b whole cube, we'll get a cube minus 3 a square b plus 3 ab square minus b cube. Then the last one, 6 cos square x plus 3. Okay, so this will get 8 cos 6x minus 12 cos 4x plus 6 cos square x minus 1. This will be 32 cos 6x minus 48 cos 4x plus 24 cos square x minus 4 minus 6 cos square x plus 3. So these two terms can be solved. Okay, 32 cos 6x minus 48 cos 4x, this will gives us 18 cos square x minus 1, which is equal to RHS. Hence proved. And here we ended the exercise 3.3.